Alright, now we're going to talk about naming ionic compounds. And ionic compounds are formed from ions, as the name suggests. A cation, which is a positive ion, with an anion, makes an ionic compound. So for instance, a cation, positive ion would be sodium, a negative ion would be chloride, and when they form a compound, they're going to make sodium chloride. An ionic compound is a neutral compound that requires equal numbers of plus and minus charges, so it adds up to 0. So we can look at the periodic table and predict what charges each of the single atom ions will have. So for instance, if I look at the periodic table, it turns out everything in the first group or first family this is starting of a new shell. So here I filled a shell with electrons, I start a new shell. So this is my first electron. So everything in the group 1 has 1 valence electrons or outer shell electrons. So what's going to happen when that makes an ionic compound is that we'll lose that electron and become a +1 charge because it's lost 1 negative. Okay? Likewise, everything in group 2 is going to become a +2 charge. Aluminum here becomes a +3. And then starting from the right, here at transition metals, they don't react because they have 8 valence electrons. It's all about getting a full octet, 8 valence electrons. These elements in group 7 already have 7 valence electrons. They need to pick up 1 electron to get their 8. Because they pick up a negative charge, their charge is -1. So all of these in group 7a have a charge of -1. Everything in group 6 becomes a charge of -2, and everything in group 5a becomes a charge of -3 because they are taking on 3 electrons in order to get that full octet. There are 3 elements that you need to know. They are aluminum, which is a +3, zinc, which is a +2, and silver, which is a +1. Okay. Alright, so a metal atom, let's say a sodium, can transfer an electron to a nonmetal. So here I have a sodium. It has 1 valence electron. It wants a full outer shell, so in order to get that, it's going to give up 1 electron to the chlorine, which needs 1 electron to get a full valence shell. And in the process, I end up with a plus sodium, a minus chlorine, and the resulting cation and anion are attracted to each other by electrostatic forces, which is positive attracting negative. This is what an ionic compound would look like, alternating regular repeating pattern of plus and minus ions. Okay? Here, this is ammonium chloride. The ammonium is the plus, this NH4, and then it alternates with the chlorine, which are Cl minuses. When calcium and fluorine make an ionic compound, they are going to make a neutral compound. So if the calcium has a +2 charge, I'm going to need 2 fluorines that have a -1 charge in order to add up to a 0 charge of calcium fluoride. If I have magnesium, which has a +2 charge, and a nitrogen that has a -3 charge, I'm going to need 3 magnesiums and 2 nitrogens. Okay. One little trick for figuring out how many of each you need is if you take this superscript, this 2, and you move it to the opposing subscript. This 2 comes down here to 2. This 3 comes over here to 3. I end up like this, okay? Mg3N2. So each of my 3 magnesiums is a +2 for a total +6 charge. Each nitrogen is a -3 charge. I've got 2 of them, so it's a -6 charge. +6 minus 6 is going to give me 0, which is what I need to have, a neutral compound. Here I have tin with a +4 charge, oxygen with a -2. If I were to just crisscross the charges, this 4 comes down here, this 2 comes over here, I end up with SN2O4, but I can simplify that down to SNO3 O2. Now, as it turns out, tin can form more than one ion. Okay, it was not part of that group that we said we can recognize. If we look back, we will see on the periodic table that there are all of these metals, these transition metals, plus all of these that we did not specify how to figure out the charges. And that's because they form more than one type of ion. They could form a +1 ion, a +2, a +3. And so in order to distinguish which ion, we have to specify which one is in the formula. That I need a +4 charge, because I have a +4 charge, that's what goes here as the Roman numeral. Okay? So the Roman numeral is used to tell me which ion of the metal is involved. And in this case, it's the +4. Okay, so the formulas of ionic compounds are determined from the charges on the ions. Sodium's a +1. It's going to lose this electron, become a +1. Fluorine picks up the electron. As a result, becomes a -1. And as a result, I end up with a neutral compound. A +1 and a -1 equals 0. Okay. So in order to write the formula, I need to balance the charges of pluses and minus. So if I have a formula that has barium, which has a +2 charge because it's in group 2, and chlorine, which is in a group 17, has a -1 charge, I'm going to need 2 negatives for every 1 positive barium in order to get a neutral charge. So likewise, if I look at these, I have a sodium, each has a +1 charge. Sulfur has a -2, so I'm going to need 2 sodiums to every 1 sulfur, so my answer will be B. Aluminum has a +3 charge. Chlorine a -1, so I'm going to need 3 chlorines to every 1 aluminum. Here I've got magnesium and nitrogen. Based on their charges, I'm going to need 3 magnesium and 2 nitrogen. Okay, in order to name binary ionic compounds, binary just means 2 elements. I name the cation first, and then the anion. So if it's a monatomic, if it's a cation that has only one possible charge, which are those in group 1, 2, or aluminum, or silver or zinc, I name the element. So I just say calcium. And for the anion, I use the name on the periodic table, but I change the ending to IDE. So this becomes calcium, just like the calcium on the periodic table. And instead of saying chlorine, I change that to chloride. Okay, so example here. This is sodium, just like on the periodic table. I change the ending to be chloride. This is zinc, just like on the periodic table. It's one where there's only one charge, which is a +2. In my iodide, so this is going to be zinc iodide. I have Al2O3, so this is going to be aluminum, just like on the periodic table, and oxide, so aluminum oxide. Now, one of the things that hopefully you have noticed about ionic compounds is we don't use any prefix. And that's because there's only one possible way to combine sodium and chlorine and get a neutral compound. And that's based on their charges, right? Because molecular compounds are not based on their charges. They are not made of ions. They are neutral without trying to balance those charges. Okay. Sodium chloride, zinc iodide, and aluminum oxide. Alright, so we want to finish these names. So this is sodium. The N is going to make it nitride. This is potassium. The N of bromine will become bromide. This is aluminum. It'll become aluminum oxide. This is magnesium, and it becomes sulfide instead of sulfur. If I look at these, calcium is in group 2, so I do not need a Roman numeral because it's always going to be a +2, so it's calcium oxide. tin is one of those transition metals that changes charge, so I need to specify its charge. And I need to figure out what the charge on the tin is based on what I know about the chlorine. Chlorine is -1, and there are 4 of them, and there's only one tin. It must be a +4 charge, so it's going to be tin 4 chloride. Nitrogen is a non-metal, so this is a molecular compound. I use prefixes, so I've got 2 nitrogens, so it's going to be dinitrogen trioxide. Okay, to name these compounds, it's going to be calcium oxide. Tin 4 chloride. I know the tin must have a charge of 4 because I've got 4 chlorines, each is one negative. This is going to be, it's a molecular, so I need prefixes. It's going to be dinitrogen monoxide. Not monoxide, trioxide, because there's 3.